All right, lesson 521, logarithms. So today we will review a very important function, the logarithm family. Mostly, like we'll refer to them as logs. Both exponential and log functions are widely used to model situations in biology, chemistry, business, economics, engineering. Logarithms are useful when dealing with very large values. They were derived from logical arithmetic and developed in the late 16th century by the Scottish mathematician John Napier, right? And so it just sped up work in the sense of how to do these things. So let's look at these two function machines here drawn at the right. So when we have the function machine 3 to the x, right? And so she puts a 4 into this function machine, right? It's going to spit out, right? So 3 times 3 is 9, 9 times 3 is 27. 27 times 3 is 81, right? And then you plug 81 into the second function machine, which is the log base 3 of x, right? And so you could use a calculator to do that. For those of you with a TI 84 and up, you go to math, right? And then down to, I think it's 0. And it should say like log base. That's what they're talking about, right? So you can plug this in here. So you plug 81 in, and you're going to get 4 to actually come out of there. Next, it says, what if she puts 2 into the function machine? So if she plugs 2 in, she's going to get 9. She plugs 9 in here, she's going to get 2 out. Okay, so what if x goes into the function machine? So if we plug in x, we're going to get 3 to the x. And then if we plug it into the log, we're going to get back out x. So how are the function machines related? They're inverses, right? They're opposites. So just like x squared and the square root, your log and your exponential functions are inverses. All right, so suppose the machines are reversed. What if y goes into the first machine and a comes out? So say the machines are reversed here. So let's say we had log base 3 of x and we put y in first, right? So we plug y in and we get an a value out, right? And so then this would be 3 to the x. If we plug a in here, we would get y out, right? Again, they're inverses. Doesn't matter what order. Doesn't matter if we square or square root first. It doesn't matter if we add or subtract, whichever one first. As long as they're the same, they're inverses. So this is kind of how this works, right? You may recall that a logarithm represents the power to which a fixed number or a base must be raised to produce a given number. So for example, right, so if we had log base 2 of 16 equals 4, what we're saying is that 2 to the fourth power is 16, right? So again, it's the opposite of that exponential equation, right? The common log base is 10. So like if you just had log of x, right? It's understood, and they won't write this, but it's understood that the base is 10 because our number system is based off tens, right? Without a calculator, evaluate each of the following. So most of this is going to be going to this exponential form to understand these. So if you had like a, for example, here, log base 3 of 9, what are you asking? 3 to what power is 9? Well, it's 2, right? Okay, let's do the next one, right? So b, we had log the square root of 10. So again, that's 10 to what power is the square root of 10? Well, we should know that is 1/2. Okay, c, log base 4 of 1 over 16. All right, to get a fraction, we know it has to be negative, right? And we need that negative number to also get us 16. So it's going to be -2 because negative takes it to the bottom. 4 squared makes it 16. Okay, d, log of 1. So 10 to what power gets you 1? Anything to the 0 power gets you 1. So anytime you have a log, doesn't matter what the base is. If there's 1 inside, it's going to be 0. Okay, e, you have log base 7 of 7 to the 5th. Well, they already gave you that one. It's 5, right? Because you know 7 to what power is going to get you 7 to the 5th. That's 5. Okay, F, you got 2 log base 2 of 16. So you could go through the process of this one. So like 2 to what power is going to get you 16, right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So it's going to get you 4. So this right here is going to give you 4, but then 2 to the 4th is 16. So what did I say about earlier about the exponent, exponential, and the log being opposites? So this and this are opposites, and they basically cancel and give you 16. Okay, let's look at G. Log of 0.2 of 5, right? So that's really 2/10 or 1/5. So it's 1/5 to what power gets you 5? Well, -1, because that's going to bring it to the top, right? H, you have 10 log of n, right? Well, again, that's a base of 10, so those will cancel and leave you n. Okay, I, we have log base 4 of the square root of 2 cubed. Okay, so again, this is 4 to what power get you, and again, you got to know that this is to the 3 halves, right? And you got to be able to do a little math here, right? So 2 cubed is 8, and that's the square root of 8. Well, that's 4 times 2, or 2 on the square root of 2, right? So looking at this, right, like how could I get there? Okay, well, obviously I need a square root, but I also need a 2 inside, right? So again, what's going to get me to that number, right? So what could I do here to make this make more sense? How could I make this a 4? Well, if I just said, well, that's 2 squared, right? What's that? That still leaves me, right, times, right? What's going to get me that half, right? So I'm looking at like 2 times what is going to get me 3 halves, right? Or that number equals 3 halves divided by 2, or keep, change, flip, multiply by 2 over 1, right? And it's 3. So times, sorry, I didn't do that right. Divided by 2, sorry, that's 1 over 2. That would be 3/4, right? So then, right, what would this look like? Okay, so this could be 4 to what power equals 4 to the 3/4, right? And so 3/4 is my answer here to make this work, right? A little complicated, right? All right, J, 4 log base 2 of 9, right? So again, I need it to match, right? So this is 2 to the second log base 2 of 9, right? Again, this is an exponent. So even though these cancel, this is an exponent. So this is 9 squared, or 81. Okay. And again, we'll dig into these. There's some log rules, just like there's exponent rules, that'll help you understand these a little better. Okay. K. So let's look at K here. This is log of the square root of b to the 3/5. So again, this is b to the 1/2 raised to what value, right? So raised to some value equals b to the 3/5. Okay, so basically this is just going to be 3/5 divided by 1/2. Again, multiply by the reciprocal. So 3/5 times 2 over 1, or 6/5. That's what we're looking for there. And then the last one, L, right? 4 log 2 of x. So again, 2 to the second, log base 2. These cancel. Again, this is an exponent. So this will be x squared. Okay, 39. Again, guys, like this is kind of confusing, and I get that. We'll get into the rules of this soon in the next few lessons, right? So 39, another useful log is the natural log. Okay, so natural log is when they use the base of e. So when you see this log with a base of e, they're not going to write this. You're going to see natural log of x, which simply means they're using e. Why? Because it's one of the most naturally occurring numbers in nature, right? And so when the base is e, they call it the natural log. So now let's look at these, the same deal. Natural log of 1. Well, I told you earlier, doesn't matter what the base is. You get 1, your answer is 0. Natural log of e, well, those cancel. It's e and the natural log, right? So those cancel and give you 1. Okay, natural log of the square root of e. So this is e to what power gets you the square root of e? We should know that's 1/2. And then e to the natural log of x. Again, natural log and e cancel and leave you x. Okay, can a logarithm have any base? Okay, can you take the logarithm of any number? So that's something I want you guys to do on your own, is just use a calculator and try a bunch of different numbers there and learn about negatives and fractions and how they work, and how your log's a little complicated because you got to think that it's still dealing with exponentials and how there's only going to produce certain numbers, because it's also just an exponent is just simply multiplication. Um, okay, and then the last few of these were solving equations, right? And so let's try to solve these a little bit. So you're talking about the natural log of 3/2 x plus 9 equals 1. So again, the best way to solve these is going to be to take them to exponential. So e to the first equals 3/2 x plus 9, right? And so then you're going to get decimals for all these guys. So you're going to be big calculators, but then subtract 9, multiply by the reciprocal, right? I'm going to let you guys do that in the calculator just for the sake of time, right? Same if you look at b, the log of -3 equals x, right? So again, you can plug that in, right? You're going to learn that this is 10 to what power gets me equals -3. There's nothing that's going to give me a negative. So there's actually no solution here, right? You cannot do that. 10 to some power is not going to get you a negative number. Okay, looking at C, the log of base 3 to the x of 2187 equals 5x, right? So this is 3 to the x raised to the 5x equals 2187. So again, this is 3 to the 5x squared equals 2187, right? That's going to just make that cleaner and then go back to log. So this is log base 3 of 2187. Oops, sorry. Equals 5x squared, right? Again, so put this in a calculator, then divide by 5, right? And square root. Okay. D, we have log base 7 of 17. Again, you can put that in a calculator, right? Equals log base 49 of x. Okay. And so once you do this, so you put this in a calculator, you'll get a decimal. Okay, once you get that decimal, you can then change this to exponential. So this would be 49 to whatever that decimal is equals x, right? And so once you do that, you'll get your answer. And then the last one, same deal, right? E, you're going to say 6 log of 1 over the square root of 6 to the third of 3 equals x. So again, you can put this whole thing in your calculator, right? And it's going to spit you out the answer for x. So pretty new stuff here. Again, we're going to dive in more into the rules and things for this, of how to simplify some of these. It's going to help us with these in the future.